Hello, welcome back. This video we are going to practice several examples about the method we mentioned before about SES similarity, which means two pairs of corresponding sides are proportional and their included angles are congruent. So if you have that information, then we can come to the conclusion two triangles are similar. Now, let's check the first example here. We have two triangles with information here. As you can see, we have some labeled angles. We have some labeled sides. So if you check the position here, these two sides and included angle is 50, and these two sides included angles are 50. It seems that we actually can try similar SES because this is a size, two sides, and also included angle. So let's check. We know the included angles are congruent. Please make sure matching the angles here. So angle B is congruent to angle F. That's very clear. So let's check what happened to their sides. So AB over DF, that's a one pair of corresponding sides, which is 12 over 8. And then BC over EF, which is another. So whenever you say, it's not easy to see, or we can just quickly check. So 12 to 24 times 2, right? And 8 times 2 to 16. So that means these two is going to have same ratio because they follow the same pattern here. So no matter what way you do that, another way you can see this is, let's see this. I'm going to write here. Let's use a different color. So I'm going to simplify. Another way to see this, since it's both divided by 4, so I'm going to divide by 4 here. 3 over 2. And then this, same. Probably we can do a little bit different. Let's divide by 8 because they can be both divided by 8, which is 3 over 2. See? If we simplify this, it's going to be the same ratio. So it doesn't matter which way you look at this ratio. We already know the corresponding sides are having same ratio. So these two evidences are going to tell us the final conclusion is we can now we can prove A, B, C, but please make sure you follow the same order here. Since we know B is matching to F, make sure F in the middle, and D, F, E by SAS similarity. Okay, so that's one way to look at this. Now let's check this one. So let's quickly check the sides we have. It seems that if we just pay close attention to the sides, 4 to 2 is divided by 2. It's like half, right? Half of 3 is 1.5, half of 4 is 2. So for the sides, it's like everything is shrinked to half of this. For the angle, this is 58 degree, this is 50 degree. Then can we come to the conclusion saying they are similar? So you can definitely pause the video, think about this question. Some students probably already noticed. The most important thing is, if we are talking about these two sides, then we actually need included angle. But apparently this 58 is not included angle. So that's why conclusion is no, we cannot prove them. Not enough information. So we cannot say for sure they are similar. To prove the triangle is similar. Because again, this is not, as you can compare to original, this is included angle, so yes we can, but this one is not, so that's why we cannot say for sure this is similar. Okay, the last example here. So this one is a little bit different from the one before. We do have two triangles on the two sides. And if we pay close attention here, I'm going to use the same color to matching the corresponding sides. So it's more like I rotate the left side triangle to the other one. So if you rotate the left one to the right one and then shrink and then enlarge it, it will come to the second side. But and also if we pay attention to the sides, let's use a different color. So 6 to 12, and then blue to 5 to 10. So if we pay attention to that, it seems that everything just double. 6, let's use a different color. 6 times 2 is 12. 5 times 2 is 10. So everything is just doubled, right? Let's use a different color to match them. Everything is just doubled. So for the size here, it matches. We don't know the third side here, so we can not say A is SSS. So it's definitely something is missing. So for if you pay special attention, there is a two intersecting lines in the middle. So what does that mean? Yes, some students probably already recall that word. It's called vertical angle. So let's label them as angle 1 and angle 2. So angle 1 is congruent to angle 2 because they are vertical angles. Vertical angles are congruent. And also, we already show that MN is and MP to QN to NO, they are having same ratio, is all following 1 to 2. So these two evidences are going to come to the conclusion, but this time you have to pay special attention about how do we match. So is M and Q similar to MN is matching to PN here, so M to P is going to be P, N to N, and then O by SAS similarity. See, that's the example I want to share with you today. One thing I really want to remind you is do not assume any information or any conclusion just because it looks like that way. You have to use the given information, or sometimes we call hidden information like vertical angles like here, then you can come to the conclusion. Otherwise, for example, if we do not know anything about the size of MQOP, then you cannot say, hey, they look like they're doubled too. So it's not really solid evidence showing here. Okay, thank you so much for watching these two videos and also study this topic with me. One thing I want to remind you, this week we are only introducing this lesson. And also we have one class work matched to this, but definitely take your time to do that. You can definitely use the other time to revise your prior work to improve your grade for trimester 1. Thank you so much for watching this video. Again, thank you for studying this topic with us. So see you soon, everyone. Take care.